We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.
Good afternoon, everyone. How are we doing? We had the test last night, and we have assignments due coming up for this weekend. So if you're here right now in the chat, feel free to say, hey, let's see if Mewbot's awake right here. We'll throw out some points. Mewbot is awake. Something weird is going on with my internets and stuff. Let me try. Google Chrome is being really weird right now. It crashed on the YouTube. So I think we're streaming. I don't see anyone here yet. But if you're here in the chat, I'm actually using Mewbot to see the chat, which might be the new way we do it going forward. So we'll see. But if you're here, say hey. Chrome is just not working. Hey, Abigail, how are you doing? Good to see you here, Abigail. We are trying to get everything working. I'm going to try to do a Control-Alt-Delete. But Abigail, if you got questions, let me know. We can do 201, 320, 474. Let me know. I might actually start using Mewbot to, like, watch the chat from now on. You never know. I'm trying to reset Chrome because Chrome, I don't know what's up with Chrome. It's being very odd right now. Maybe we'll just go over to Edge browser. That's a bad idea. No one likes, oh, there's Google Chrome. I'm ending all these Chrome tasks on the computer. And that's Google Drive. I was hoping to get some 475. Yeah, Abigail, what are you wanting on 475? Let's do some 475. So the good news is I don't need Chrome to do that. Up, Chrome's working now. Some reason Chrome was still running in the background. So I'm using, okay, now it's working. I went over to the chat on YouTube. There we go, live on Office Hours, cool. It's working now, awesome. I might start using Mewbot to read the chat. It might be a good idea because Mewbot actually sees the future before we do. He's in the future. He's always over there watching things.
I am Mewbot.
Oh, he's mad about that. I showed up and did. Oh, Maria, that is so awesome. Congratulations, Maria. Maria, what advice do you have for people who showed up on the hashtag showed up? I love that right there. I hashtag showed up on the exam and did well. And Abigail, let me know which question you want to work on. I'm going to get the decomp assignment open as we're talking right now. Maria, that is so awesome because it was not the easiest of exams, but congratulations. That's it. Just once again, we always say how just show up to class, do the assignments, and ask questions. And that doesn't mean you're going to ace the exam, but it gives you a good probability of doing well. We're in the business of predictive analytics, so we'd say there's a good possibility you'll do well. So that's really awesome right there, Maria. Congratulations. Put on a little music in the background, but I'm proud of you right there. That's awesome. We always say just like show up and then do the work, and worst comes to worst, if the exam doesn't go well, you've got a bunch of grades to pull you up. You got a bunch of grades that are going to help you out. Confusion on 4D. Let's go check out 4D here. Okay, let's do this right here. Come on. Yes. Okay, let's go look at this. I've got some stuff to show right here. Let's go to the main screen and go. Let me take a timestamp and see here. I'm going to try using Mewbot for the first time right here to read chats. We'll see if I like it. To change the pace right here. So BES 475, assignment 4, question 4D. Let's go talk about it here on the main screen. Awesome. Here we are on the main screen. We have redo the classical decomposition. Now, the number one thing you're going to see right here, and let me see here. Can I tell Mewbot to drop links in the chat? So I'm going to try right now as the streamer to ask Mewbot to talk about the thing, and he should respond to my commands. Let's see what he says. He's supposed to at this point. He's going to tell us about that FPP3 book. Oh, maybe I can't talk to Mewbot from here. Maybe it's FPP3 or FPP. FPP, there it is. FPP stands for Forecasting Practices and Principles. So this is the book we use for the class, and we need to basically use some of the methods in it. If you notice what this question's asking about, it says the classical decomp. So whenever you see code like this, it's always cool to go over here and just grab from the book, and boom, we're inside of it right here. So we can see the classical decomp method, and now we need to understand what is going on. Can we go over 2B? Yeah, let's do some 2B next. Honestly, I'm not sure if I have the right step. Yeah, Shiv, great question right there. Thank you, Shiv. Let's throw out some points. Shiv and Abigail, great to have you here. And Maria, awesome. If you have questions, let us know. So what is a decomp? I wish I hadn't closed the notes from yesterday. Can anyone explain in the chat what is a decomp? Like, let's look up here at the top. We got a series right here. Go down here to that. Here's a series of data. We're looking at the employment of U.S. retail right here. So this is like retail employment in the U.S. Like you go to like, you know, Best Buy, Circuit City, and you've got peaks because I think this is monthly data right here. So we're looking at different peaks right here, different like low points, and then you see sort of a cycle, sort of a trend. Taking apart the data to identify the patterns. Boom, Shiv right there. Great answer, 100 points. Shiv is right. We're basically taking the data and breaking it down into these components. So you take this original data, we'll just show just the original data. Here's the original series right here, and then we're decomposing it into these. It's like, you know, if like you had a cake and you say, okay, I'm going to take all the icing off this cake. I'm going to take the cake parts out of this cake. You could decompose it down further, but usually would be like, okay, here's the icing, here's the candles, and here's the cake. So we're going to like decompose it from the built cake into the icing, the candles. And actually, rather when you think about it, think about this. Here's what it would be if you break apart a cake. If you break apart a cake, the largest component of a cake is the what? So use the cake, icing, and candles analogy right here. If you think about a cake, icing, and candles, the largest component of a cake, which is mainly the thing you say when I want some cake. If I say I want cake, the main component of a cake is going to be what? The main component of I want cake is going to be what? To think about what this all means, we have to like give it some context for our mind when we look at this information on the screen. The main component of a cake is going to be the what? It's a redundant question though. The main component of a cake, the cake itself, Shiv right there, cake, and even more points, Shiv right there, the cake itself. So this is the cake itself. This is the icing. And then, why did the cake analogy actually really go? I know, it does, right? And then you're breaking it. I think of these things like, how does this, like, what are we doing? This is your put together cake. This is the cake that's been all put together with your cake component, your icing, and then the candles on top. And then you break it apart and you just say, here's my cake, here's my icing, and here's my candles. So what are we looking at? Well, the biggest thing to notice, especially for 4D, is these components right here. Now, we've been talking a little bit over, and this actually calls it random. Really? Really? We need a fourth name for it now? This is the remainder, the irregular, the residual, the random. It's just what's left over after we look at these two components. The two components right here to start are the trend, which does include trend, which is like a linear trend, but does include a little bit of cycle, which is a non-fixed pattern. What do I mean by non-fixed pattern? A fixed pattern is going to have the same interval, as in like this is like every 12 months. It is monthly data. So this is every 12 months we see the same sort of fixed pattern, and that is what we see with the seasonal pattern right here, the seasonal content of the series. So when we look at this, we're actually seeing the major components of it. We're seeing the trend, which is going to be like linear and a little bit of cycle. And then we're seeing the seasonal, which is going to be over a fixed pattern. And it's still a major component, but the very small remainder right here is going to be the random, the residual, whatever you want to call it. It's just what's left over. So you can kind of see this. If you notice is that dip right there? You might be able to trace up and say there's a dip. That's that dip right there I think we're seeing. Is when it dips down, but that's also part of the trend. Sometimes the remainder, if it's very small, is hard to see. And Adam Spanbauer had some good suggestions. I like looking at this box right here. But Adam Spanbauer said you can basically get an idea of what's the biggest component, and this is a quick way of looking at it, by just looking at the axis scales. So which of these looks to be the biggest component, 1, 2, or 3? Now, don't be tricked. Don't be tricked right here. Look at component 1, 2, or 3, and just look at the axis scales. He had a good suggestion in the Discord to say, just look at the axis scales. Like you can look at the perspective thing. I talk about what the perspective thing means, but it's kind of the inverse of what you would expect. But just look at the axis scales and think about money. If you think about money, number one, exactly, Abigail, great answers right there. Abigail, you're right. Number one would be the biggest, because if you just think about money, 16,000 to 13,000 is a very big difference. That's a terms of 3,000 difference. Negative 200 to 600 is a difference of 800, and this is negative 100 to 100, so that's a scale of 200. Now, these things right here always have the same unit length. So if you look at this right here, this thing right here is the same size as this, is the same size as this. It's just that the axes are different. I think that confuses people, because if I say which one is the biggest, they'll look at this. But probably an easier way, like they almost add that to confuse you, right? But probably an easier way to think of which one's the biggest is just to say, oh, this one goes from 16,000 to 13,000. So this is a much bigger thing right here. Like it goes off that range. Like think of dollars, where this is only negative $100 to $100. That's a much smaller range. And once again, that square box over there, that rectangle, I don't know shapes. That rectangle over there is the same size in all these pictures. So this is a much bigger thing comparatively to this perspective object right here. So it's a much smaller thing. It's even smaller than the perspective object. Like that whole series right here would be contained within these bounds right here. It'd be a little squiggly line doing that. So understanding what this is communicating is important. So to 4D, to go like talk about what 4D is doing. Once again, the code, and I want to point to where the code is at. I'm going to literally drop the code right here in the chat for you. This is the classical decomp, and you really just want to take these codes and run them. I just dropped them there in the chat. You want to run the code. You want to use your series. You want to use either the additive or the multiplicative, what the question suggests. Use the series. If you notice right here, it's got everything you need with the model. This is the variable you're using, so you'll need to change your data. That's your data frame you're using. You need to change the variable inside the data frame you're using. Then you need to extract the components. You need to auto plot those components, and you could throw some nice labels on if you want. Labels never hurt to explain what your pictures are. So if you have any problems with the piping through of your code, let me know. Abigail, are you all right with that? Because I'm guessing at this point you have your pictures, and you're wondering, theoretically, it says, are there any noticeable differences between the two? So when you look at this, so I don't want to directly give the answer, but I think if you're looking at them now, I've got a decomp on here. If we go and look at a decomp, we did a decomp yesterday, and I used a different data set. Here we go, X11 decomp right here. And so let's auto plot it. We're just going to throw an auto plot on this. That should auto plot our decomp. And no. Okay, cool. It doesn't want to auto plot it. Why wouldn't it auto? Oh, because we're storing into the object. That's why. We stored it. Okay, there we go. And let's take the X11 decomp. And let's not store it. Let's run what we have as an auto plot. There we go. Okay. So yes, piping and code is good. Awesome. So here's our X11 decomp right here. And what we want to look at and think about as we compare things is, does it take more information from something? Is something a larger component of the decomp? Very clearly right here, just one word in the chat. Very clearly right now, the largest component of the decomp is what? Very clearly, the largest component of this decomp is what? Because then we want to compare it to another decomp, which we could do. The very clear largest component of this decomp is what? Very, very clear that the largest component of the decomp is what? The trend. Great job, Abigail, right there. Very clear that the largest component of this decomp is the trend. Once again, you could look at the scale or the perspective object. It's very clear, like it's very similar to the main series, and that's where a lot of the variation in the data. When we say largest component, we're saying a lot of the variation in this data comes from the upward sort of trend and cycle to the data. That's what we're saying when we say, what is the largest component? Like, what is controlling the employment of people? It seems to be the upward trend. But there is a very very sizable second component right here, the seasonality. So the seasonality is impacting it, but not as much as the trend. So we would then say the seasonality is the second largest component with a remainder down here on the bottom. Now with this, if we are to compare this, we could look at these perspective objects. So Abigail, tell me if you need more hints or helps on these. I don't want to like directly answer, but you could look at 2D comps to say this is getting more information from this. Now be careful because it is reverse. Well, the trend, it could, good question, Abigail. I bet I could find one. I'm thinking if I know of a series off the top of my head where the trend's not the largest component, I can draw you a series. We're going to get a billion word documents, I bet. Oh my gosh. Wait. Oh, what's going on? What have I done? That's all the work we've been doing. I can draw you a series. This would be a great visual test question, Abigail. Draw me a series where the trend is a very small component. Do you see it? Because the trend is very what right now, Abigail? So the trend doesn't always have to be the largest component. That's such a great 100-point question right there. The trend doesn't have to be the largest component because right now the trend is what? Like the trend looks to be very... Like if you think, why is the trend not a large component here? The trend is a kind of. The line is also very what? You are correct. It's linear, but it's not linear like this, where that would have a very large trend component. It's linear like this, which goes to 201 with correlation and stuff. The linear trend is very close to this. So you're on the right track with that. The linear trend is very close to what? Yeah, it's very close to 0, right? So if we were to talk about 201 concepts, I always love bringing it back to the early courses. We would say that the correlation of this data, the linear correlation, is very close to 0. And yep, exactly, Abigail, perfect answers. The correlation is very close to 0. So due to there not really being any sort of linear strength to the relationship that we would see here in this plot, which I'm trying to think if I know a series that looks like this off the top of my head. Here, let's go. We might be able to find one really quickly. That's such a great question that I'd love to see it. Let's take a moment right here. Let's put on a tiny bit of music and see if we can find one. And then we're gonna do Shiv's question next. But let's see if we can find. We got the FPP3 loaded up. Okay, so data. We're gonna see if we can find one. FPP3. I will throw 500 points if we find a series that does not have a strong linear component. Here's FPP3. Australian passengers arrival. I don't know if there's a way to get only the data sets of FPP3, because this is all time ordered data. You can grab it like this. Oh my gosh. Well, that's horrible. Okay, here we go. This is quarterly data. It's quarterly data. We'll give a few tries right here. No. Do you see the trend components of these, Abigail? Those got some good seasonality, but they've got linear. These ones down here might have less of a linear component, but these all have some sort of linear component. So that's a no-go on that one. We don't win on that one. Lost passengers. We're just taking a few shots at these and seeing if we see anything worthwhile. My brain didn't work right there. Try just a few more. Oh, that's very much trend. Flood trend right there. It's yearly, so we don't even have seasonality. Also rivals. Bank calls. Try it. We'll try 3 more and see if we get one worthwhile. Boo! Abigail, thank you for following along. I always think it's fun to look at data. Data is just interesting because it tells a story, and then we have to have ways of communicating that story. Oh, I wish I had my ba 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 ba. I do. It would have been better if I knew it off the top of my head. We found it, Abigail. We found it. This is a very a data set with not a lot of trend to it. This is a lot of seasonality. And hey, what's up, Troy? Good to see you here, Troy. 100 points, Troy, being here. Drop those questions. We got some chapter 7. We're actually kind of talking regression right now, Troy, which is our next topic for 201. We're talking about it at the 475 level. And you can see here there's no linear relationship in this data. And that's what we're saying when we talk about trend. We're going to see a big residual over here, Abigail. And we're going to see a big residual over here, Abigail. Yep, you can make sounds in R. We can do like Mario and stuff. Or shotguns. That's a Doom sound. There you go. Like, there's... Oh, did I mess it up? Oh, I think oh, yeah, I edited the file because I was trying to get it to play my own sounds. Yeah. Oh, Bully the Stats 1 exam. Great job right there, Troy. Great job, Troy. Great job, Troy. Troy, do you have any suggestions? We'll be talking about that next class. You might even get an email from me saying, what's your suggestions for students? Troy, great work. Abel, we're going to take this data set right here. It thinks we want to do calls. That's good. We'll tell it to do calls. Okay, cool. We're going to take this data set and we're going to look at it in the decomp. So all we have to do to make our decomp is we're doing the decomp just like we did. We take the data set and then we're going to go over here to calls. And so this is the X11 decomp and it's mad about it as it should be. Is it not called calls in here? It is called calls. What's it mad about? What is it mad about? Oh, can it not be used for whatever kind of data set we're using? It has gaps? Oh, come on. Really? Let me see what's going on with the data. Let me see. Okay. It says the data set has gaps. Bank calls. So let's ask if there's missing data in this. Is.na. Bank calls. Let's do a sum of those to see. So right here, Abigail, nothing is easy anymore. I agree. We're doing this to see what? There's no gaps. There's no gaps in this data. There's no missing data. There's no missing data. Warning. One error in X contains implicit gaps. You should check your data and convert implicit gaps into using the Tizble fill gaps. Okay. Well, let's just call that function and just run it through it. So let's take sure, let's just try it. I don't use that function a lot. Bank calls, sure. That's calling the library it's in. Okay, cool. Okay, sure. So now let's overwrite bank calls with that. We're just going to overwrite with the filled gaps because it says I have gaps. Okay. Now it shouldn't say I have gaps unless it wants to be me. Oh, look. Errors. Seasonal period too large. See section 2.7 for reference. Oh no, Shiv. The more things we have. Problem with mutate column component. No applicable method for component applied to an objective class null model. So it made a null model. Null model means model. I think the most important thing was for practice. Yes. Without your notes in front of you. And with this, yeah. SI helped a lot. That's so good. I'm glad to hear the SI practice helps a lot. We want always everything to be as productive as possible. Time series cannot be read due to previous found errors. Specify. It's mad about the series. There is gaps. There are lots of gaps. This right here is a gap in the data. This is a gap in the data. Date time 5 minute. These are large gaps. It might even destroy the data. Well, this is a messy data set. Those are large gaps. Oh, and it's 5 minute periods. Oh, wow. Yeah, it is strange. So you'll get a connection on a line plot right here between points where there's no data. So this data set is rather odd. So yeah, we should have learned more about our data before using it. I mean, that's my fault. It's every 5 minute interval. Every 5 minute interval what this was collected on. So, and actually, well, I'm working with another student on another project where they have not like quarterly data. They have like fall, summer, spring, summer session 1, summer session 2. So we've been looking at that, but that's such an irregular thing going on right there. Well, okay. We got one last try at this, and then Shiv, we're going to do your question right here. Boston, it's yearly data. Canadian gas prices, monthly Canadian, it's probably just going to go up. Data, come on, Canada. So that was the problem right there, is that data is over every 5 minutes. And that data has a bunch of gaps, so we can't make the decomp. This is going to be, that's got a huge trend component. You can see the trend right here. You can see the multiplicative seasonality. Do remember, how do you know this is multiplicative seasonality? Shiv and Abigail, how do you know this is multiplicative seasonality? So for 201, you should say, oh, there's a little bit of linearity. Is it straight enough? And then for 475, you say, okay, we've got linearity and we've got some sort of cycle component, the plot thickening. Boom! Abigail, great answer right there, because that's the 201 way of saying it. We say the plot is thickening in this area, meaning a heteroscedastic or change in relative strength of the model. Plot thickening, Shiv, great answer there too. So that is an indication of a multiplicative model would be better, or multiplicative decomp. So those are the things we need to know and be like, okay, this is some sort of spread difference. So we probably need to use a multiplicative method, which can then account for the differences in spread. So we're going to try 2 more series because I really want to get a series that we could decomp that doesn't have those gaps. Okay, let's try looking at 2 more. What do you think, Shiv and Abigail? Oh, well, that's pure linear. It's yearly. Doesn't even have any. What do you think about this whole piping method right here, where we can just take and run it through an auto plot? Any thoughts or... Ooh, I think we found something. Not that long. We might have something right here. Insurance, and we're doing quotes. Might have something. Okay. Insurance or quotes. Hopefully, it doesn't look like any gaps in the data. Okay. It looks like we're doing better. So let's see if we have the series we are looking for. Is this the series we are looking for? Love the Mario pipes. Mario pipes for all day long. So we are doing the insurance, and we are doing quotes, and it says it's good. We are happy. And then we're going to go right here, and we're going to run it through the auto plot. There's our Mario pipe. Gotta love some Mario examples. And yeah, look at this. This is a very different decomp. Very different. So this one, ooh. What is the biggest component of this decomp? Be very careful. They're all very close. What is the biggest component of this decomp? This is a very interesting decomp. Yeah, great job, Shiv, right there. And then we're gonna do your question next, right after this. Looking at this, what is the biggest component of this decomp? They're all kind of close, but one of them wins, and that's not good. It's not good. What is the biggest component of this decomp? You can call it many different names. It's that thing that's tomato, goes by many names, and we wouldn't want this. What is the biggest component of this decomp right here? Abigail, you're right. This is sad music right here. The remainder, this component right here is the biggest component. So there might be ways to adjust this decomp to maybe use a multiplicative, an additive model. The way of doing it that we did right here, a lot of it is just going to the miss of the model, the remainder, the irregular, the residual, the random. This is not what we want to see at the end of it. This is the unexplained portion that we did not get with the trend or with the season. So not only does this not have a strong trend, this doesn't have a strong seasonal component. And you kind of notice it doesn't really follow like a good pattern. There's a little bit of flowy. It's not even really trend, it's more cycle. So cycle's the irregular pattern right here. Not that it's irregular, but cycle is a non-fixed pattern that we see over time. We don't really see a linear trend. We don't see strong seasonality. There's something, but it's not a big component. That's that little peak there, a little peak there, a little peak there. So this is what it gets when it tries to impose a 12-month seasonal pattern on it. And it's something. It's in there a little bit, but not much. But over here, this is the remainder. Oh, mods, if you have... Let me go over to the stream. I can see the stream now. That's why I need to be in the stream. I'm going to block that chat right here. Oh, bot's in the chat. Bot's gone. Awesome. Well, great work. Let's go take a look. Oh, Troy, you changed your icon. Cool, Troy. I can't tell if I like this new way of doing MuBot. He sees the future, so I actually see things quicker. So if you reply in the chat, I will see it pretty much instantaneously. So I want to do one quick test right here. Who wants to help me with this test? And then we're going to do Shiv's question right here. So let's go to the main screen, then we'll do Shiv's question. Okay, I'm going to take a timestamp. Who wants to help me with this test? I'm going to do a test of the stream because I want to see this, because maybe this is a better way of doing it. We're testing new tech today. We're testing new ways of doing stuff, new ways of teaching. Assignment 4. Shiv was wondering about 2B, was it? Question 2B, was it? Let me double check, Shiv. Shiv said... 2B, yeah. Let's see. You want to help Shiv? Awesome, Shiv. You ready? Okay, Shiv, so what I want you to do is when you hear me clap, I want you to just type 1 in the chat, okay? So when you hear me clap, I want you to type 1. I want to look at the latency of this, okay? So have 1 already typed. Like, don't type it when you hear me, but have 1 ready to go. Got it? Okay, well, and then just hit boom when you hear me clap. You ready? Here we go. 3, 2, 1. 1, 1,000, 2, 1,000, 3, 1,000, 4. I'm on about a 3.5 delay, 4-second delay. So there's what's called latency in streaming. So it looks like I'm on about a 4-second latency. So whatever you type, I will see about 4 seconds later. So pretty cool. That's not bad. 4-second latency is pretty good. So I want to see what you're typing pretty quickly, because then we can do pretty quick back and forth. But I'm on about a 4-second, which is pretty close. I wish it was just instantaneous. Did you click it? Yeah, not bad, right? Like it. It's a little bit quicker. So I might start using MuBot to look at the stream especially during office hours where we're trying to be more instantaneous in our communications. Okay, let's go look at Q2B. And I've got some stuff up for it. Okay, so let's go look at Q2B. Yeah, I know, right? I actually see it appear right now on ad points. Ad points, don't mind if I do. Let's go to the main screen. Mubot's taking his time on. Oh, wait, I went to the wrong screen. He didn't add points right there. Maybe there's something. I don't even see Mubot adding points in the chat. You're right. He's replying to that, but it's not adding the points. Have I not added points all today at all? I don't see him adding points either. Let me reset the stream deck. Okay. I can manually add points. Watch this. Points, add, plus, viewers, 500. There we go. Manually adding points. Mubot will respond now. 2 seconds. Let me bring up the stream deck. So maybe we found a problem with doing it this way. I see things faster, but then Mubot doesn't like me adding points with the buttons. He's not adding points with the button. All right, I might have to manually. Maybe things were a little bit weird when I booted up today, so maybe we'll look at that. But I can still manually add points. I just don't have the ability to click it on my stream deck with the buttons. So there's how I can add points. But Evil Tiny Brian tier, awesome, man. Evil Tiny Brian.
I'm not evil.
Yeah, you are, man. Okay, question 2 right here. For each of the following series, make a graph of the data. If transforming seems appropriate, do so and describe the effect. So show both the series. I'm going to retimestamp this. And then transformed series. Comment on the changes of the series from each of the transformations used. So this is about just taking our data and turning it into something new and applicable that we can work with. So when we talk about transforming, we're changing the what of our data. So this goes to 201, Troy. Who knows? If I talk about, so Troy, watch this. You ready? If I take some data right here, like exponential data, which is not normal, and we'll see this right here. Am I allowed to send you my code? Yeah. Send it on the Discord. Send it on the Discord. So drop it in the Discord, and then I can take a look if you want. So if we have our data here, and then we go here and say log 10 of x, we can then make a histogram of these values. And Troy, or Shiv or Abigail, what have we changed about our data when we get to run? What have we changed about our data? From the original data to our new data, what have we changed? What have we changed? Main equals original data. Let's see here. The shape. So exactly. Transformed data. So if you look at this, it really goes to, oh, we didn't. Boop, boop. There we go. So here's the original data that is very, very right skew. Here's the new data, which has a little bit of less skew, but is more normal. So a lot of times in statistics, we are looking at the horizontal. Yeah, exactly. The shape, boom. That's Troy, exactly it. So what we learn in 475 is we can use transformations. 100 points, everybody. Mubot, you want to give out points again? He's mad. I don't know. Let me try this. I'm going to reset Mubot. Okay, so I'm not going to see anything. Okay, resetting Mubot. Might be a problem with Mubot today. Mubot's crashing the world right there. We'll see if this fixes Mubot's reawakening. He's about to see if that'll fix it, and then we can give out points normally. It's weird. He doesn't like to appear sometimes. I got to click his button multiple times. I do not understand why that does it. And it says I need to update Mubot, so maybe that's part of the issue. I do not understand. Okay, so now let me hit the points button. Mubot isn't just having it today. Let's motivate him. Oh, Five Nights at Freddy. Oh, yeah. Oh, yeah, that's what they say with the bots, right? They're like, Freddy's not having a delay. Let's control him with a shock right here. Five Nights at Freddy's. That's good reference right there, Troy. Well, he's not. I don't know what it is. Here, let me do this. Mubot's not happy about that, I think. He's not happy. I don't know. Oh, yeah, we'll put him in the shop. I don't know. He doesn't want to appear on the screen. He doesn't want to do it. I swear he exists in this reality. Oh, wait. What? What is going on? Okay, it turns out there's two Mubots. Okay, I'm going to focus. All right. Yeah. Okay. Well, I'm finding the problems. I'll fix this later. But 2 Mewbots. Okay. With this, let's take a look right here. We are trying to transform some data. Now, you have different series than me. You have a different series. I'm using the code right here. We wrote this code during a different stream, but there's an evil Mewbot too. We've got right here the Australian livestock data. We are taking the Tasmanian state in Australia. We're taking the pigs. We're doing a color of UT orange, and we're storing it into graphic 1. So this is a lot going on right here, but I want you to read it as pipes and read it as parts. The Australian livestock data is the first thing we're using. We are simply looking at an Excel spreadsheet for all intents and purposes. Does that make, like, can you follow this? That the Australian livestock data, and it should show it over there, Australian livestock data. What is this right here? Australian livestock data. Where is it? Is the question. Australian livestock data is just a what? For all intents and purposes, we've seen this many times. Just repeat after me. I am just looking at a what right now. Like we overcomplicate these things in our mind sometimes. Repeat after me. That thing that Brian is showing me inside of R, Shiv said it perfectly. Mewbot, give out those points, man. Is just an Excel spreadsheet. Oh, Mewbot's fixed. That's weird. He is fixed though. That's just an Excel spreadsheet. That's all that is. You just see an Excel spreadsheet. Just pretend I've opened Microsoft Excel. I'm good to go. The next step we are doing is saying I only want to see Tasmania. So once again, you are looking at an Excel spreadsheet right here. This is just an Excel spreadsheet in your window of only Tasmania. Tasmania being a state inside Australia. That's about as much as I know because it's in the data set. But that is a state inside Australia. Now, there's a ton of different animals. What would be really interesting is we could actually take this at this point. Autoplot is so amazing because Autoplot will actually plot all the different animals for us at this point for Tasmania if we stop and Autoplot at this point. So this is a bit of a mess. I would not suggest this, but there is one quick fix to this, which is awesome. Shiv, watch this. If we go here and take this whole object, and actually we can do it an easier way to think about it. Let's just call this messy plot. So we've got here a messy plot, which we just took this thing and stored it into this. We can use a function called ggplotly. And so we take the messy plot and pipe it through ggplotly and watch this. Now it still looks messy, right? But look at this. There you go. What are your thoughts, Shiv, Abigail? What are your thoughts on this right here? If you just take this thing right here and pipe it through a ggplotly, you can then do the following things right here to take a look at it. And we get all of this for such little work. Why would you not have selected an animal? Because I would at this point, so we're going to select an animal here in a second. But if you are just doing like data investigation purposes, you could use stuff like this right here. We get along well. I love ggplotly, except when you try to knit it, then you're going to have a bad day. So I agree right here. I like using but it sucks. Exactly, Shiv right there. 100 point Shiv and Abigail right there. ggplotly's awesome, except when you want to knit. And then it says no. Ooh, Abigail. Remember that? Abigail, we should look at this. The calves, what do you notice right here? There's very little to know what component of this. Also, this would probably be a multiplicative decomp. And this is what we're learning. Like, we want to learn what we're seeing right here. We're seeing a series with very little what component to it. We found one. We found our series that we were looking for so intently. So after we finish this, little trend, Shiv and Abigail for the tag team duo right there. Yeah, that's very little trend. Some increase, decrease in seasonality because the seasonality is not constant. But the calf production or slaughter in Tasmania is very, very consistent in its seasonality, at least in the, not the magnitude, rip the calves in Tasmania. So it's very, very consistent in, there's a strong seasonal component, but the seasonal component has different magnitudes. And that's what's indicative of a multiplicative decomp versus if we were to see a consistency, that one's more consistent. That's pretty consistent. A lot of remainder right here, a lot of stuff. So we should remember those calves. to look back on that. Pigs, less variation. So that's got some trend in it. Yeah. So yeah, we can take a look at that here in a moment. So now we're just narrowing down further to just the pigs. Once again, you're not going to quite do like this, but we're just filtering down further. We're saying, okay, here's my data. I'm going to then only look at Tasmania, and then I'm filtering into just pigs. And at this point, I'm doing an auto plot right here to just get my one picture. Everything on here is just little Salt Bay accoutrements because now we're just adding to the picture. So I think this is where a lot of confusion comes into play. You might think, why am I not piping this through? We've actually created how would you plot it for the entire country instead of just one specific state? Oh my gosh, Shiv, let's do that next. Let me write that down because I should be able to figure that out. I teach the class. We want to do like an aggregate, or we want to do a summarize. I believe we want to use the summarize function. That's such a good question. So because someone would probably want to know that. So we probably want to go using summarize to plot for all states. That's a really good question, Shiv. Shiv, that's a 500-point question of the day. I like when we try to think of things outside of what the assignment does. And that's what we want to do. We're not here to just complete an assignment. We're here to ask questions like that and say, well, what if we want to do it for all states? And we can do that because we should be able to summarize it. And just think about what we'd be doing. What would we have to do, Shiv? Theoretically, Shiv, what do we need to do mathematically to plot for all states? What do we need to do mathematically to plot for all states? Like, just think if we wanted to look at all the states, this isn't all the states, but we would need to what all the states together, like for their pigs, for their calves, or if we want to look at all the things for Tasmania, we would have to sum them all at first. Yeah, sum them all together, sum all the slaughter first. That is correct. No veganism here. No vegetarianism here. So sum all the slaughter of the animals. Sorry, animals. Sorry, Cosmic Skeptic. He would not be happy. Or any other vegan. So all this right here is adding the title. So if you see what I've done right here, we get a plot, and then we're not going to pipe the plot in. We're going to add to it. So we're just adding a title, and then this is adding a center. So these last few arguments are going to put that title there. This is also from a library, GG Easy. If you ever type something and it doesn't appear, it's because you don't have that library running. So you want to make sure you have the library right there, GG Easy, unfortunately. And so I've gone a little bit vegetarian, and then I've stored it into this object. So you could, if you didn't have the object up, you could then run this object. Now I'll explain why I'm doing this. This is the original data for pigs, and then I'm going to go through here and do a transformation. So this once again brings us back to the idea of what is a transformation. So when you do a transformation, you're taking this original data right here, and you are going to transform it in some way. So we want to find a value of lambda oftentimes, and here is where's my value of lambda being found? I know, Shiv, we were talking about this, right? You got me the code for it. So where's my features Guerrero? Well, I might need to do it again. Is it not here? Okay, let's go find that Guerrero feature. Can I do it? This is good practice from memory. Brian is going to go find the optimum value of lambda. We'll talk a little bit about what the lambda is. Okay, so we need to take our data right here for those pigs. There's our data. And then we're going to pipe it through feature. Features right here. Whew. And then we need to get the variable name. The variable name is count. Then we need to give the feature we're using by calling feature equals. And then it's Guerrero, but it has no thing on it. We've done it. Yes. There we go. Practice. Just got to do it a few times or look it up in the book. Book is excellent right here. Book is a big help. Do I understand the book code for us to see the book in the chat? Is FPP or FP33? Check out the book. The book has all these step-by-step processes. If you Google one of these things in the book, you will then be brought to the page with all the Guerrero ideas. There we go. And so you can go and check out on how to use it, and he shows step-by-step on how to use it. I should have used that pull lambda right there. We're going to pull this column, and all this is doing... I like to space my code like this. Oh, wait. No. We're going to pull, and this pulls that information. There we go. So this object right here, or this value, What does this value mean? We're going to call it L value for lambda value. And look, we already have it up there stored multiple times. So what is this lambda value? Lambda allows us to do what? A family of transformations. And let's look at the code. Lambda is a family of transformations. What do I mean a family? When I say a family of transformations, I mean there's a bunch of whats when you use the lambda transformation. Did I lose it? Here it is. When I say a family of transformations, what does that mean, Shiver Abigail? If I say lambda is a family of transformations, I'm just saying to you there's a what for transformation options. Like translate that, because someone might say, what do you mean a family of transformations? Family? A useful family of transformations? Think about instead of just a singular transformation, it allows for the options of whats. What does it mean if I say it's a family of transformations? Because we could just say, like, if we talk like normal people, we would tell people what? We talk like statisticians sometimes. Different types. Oh, yeah, boom. Great job. Shiv, perfect answers today. You got it, Shiv. Yep. Shiv was just saying all his answers with confidence. Love it, Shiv. Great work. So the lambda value we're choosing is right up here. And so we can choose different values of lambda, which are going to change the series. Now, when we go to 1, this is basically original series minus 1. Now, what we often try to fix with transformations are things like non-constant spread, i.e. plot thickening, and also with issues with linearity. Because if we can get a really constant spread and linear relationship, that's much easier to predict in the future than things that don't go linear or change in scatter. So we want something to be very constant. So I think the optimum lambda is maybe closer to about here, they're saying. You've got more consistent spread, but you see there's still issues of linearity. Transformations are not going to be perfect. We're not going to get something like, oh, that looks perfect now. I mean, you could. It's possible. Often you don't get something perfect. Often we're not going to see some amazing, and you could do something like this. You have to find the right value of transformation. This is way worse. This over here is way worse. We're trying to find that happy spot that creates the proper relationship. And people like Guerrero right there have worked on ways to assess what is the best linear constant scatter relationship and what is the optimum value of lambda. So basically what you're doing by running the code is you're auditioning different values of lambda. It's going to test for you and say, let me look at your original series and find a value of lambda that could really help. This is the one we did last time we did Tasmanian pigs. Let me choose a different one and see if we can maybe get a different, better transformation. So let's go with New South Wales today, and let's look at the pigs in New South Wales. So here's the pigs in New South Wales. Are we getting the auto plot of it? So we're going to go to New South Wales pigs. And so we're just going to pipe through here and get the proper value of lambda. We need to use a lambda value of the following, different than our first. And then we're going to change this to New South Wales pigs. And so here's the original. Oh, we're not looking at it yet. Here's the new. Ooh, that's a very interesting change in the series. A lot of seasonality. And now we're going to take that L value. And this time, this is where we pulled the lambda. Well, sure. We already did the work right here. It's the same work we were just doing that we practiced. And we're doing it for New South Wales now. And now we're going to use, instead, we're going to auto plot the count, which is the Y variable, with the L value right here. And we should get a different plot. I'm doing all these extra things. It's the same code that I wrote last time, but now we're storing it into a red graphic. And what do you think? This is right here. I've got a lot of extra code right here. But Shiv, I need your thoughts on this. This is a good example. I don't want that title. Text. I didn't change the text, did I? We're in the same boat as we were last time. Wow, that is about what? I don't want to give my thoughts on this, but I mean, there couldn't be a better title to this data ever. What are your thoughts on this graphic? There couldn't be a better title ever. I barely noticed a difference. We're not achieving goals of, maybe there's something with the spread, because you notice here it's a little bit smaller, here's a little bit bigger, this looks more consistent in spread. If anything, I noticed changes to the consistency of spread, but no transformation is going to fix the sudden shift in the series. There's this huge, if we decomp this, which we should be able to do pretty easy now that we have all these codes, is we want to take and filter. Watch this. We're going to take this data, we're going to bring it down here, and we're going to call this filtered data. Filter data. We're going to take filter data down to our decomp that we were running. And so we got all our decomp code that we were looking at. This was cool. I just love asking questions because we're going to see a huge irregular component right here. So we go down to our decomp code. We don't need all that. We just need the decomp code. And we're taking our filtered data. We're going to do the, is it count? I think it's count, right? And whoop, whoop, whoop. We're going to go to count. There we go. It's working. And now we're going to auto plot that decomp. And it's actually picking up in the trend. Huh. The trend component's very large. And I thought it would... The seasonality is really not that awesome here. Does that make sense? And let's look at those calves in Tasmania in a second. But there's a huge trend component to this. The seasonality and the remainder are overlapping. The seasonality of this is really irregular. So what we see right here is mainly trend. So that makes me think we haven't even learned this method yet. But I would say like a piecewise regression. A piecewise regression or something with exponential smoothing. We're going to learn new models. But when you think about what I would use right here, if it's mostly trend, you can use, we might even not use a Holtz Winter, or maybe a Holtz. You want to hear the coolest thing, Abigail? Which of these two do you think is an exponential smoothing that deals with seasonality? Holtz or Winters? This is the easiest thing in statistics to remember ever. Thank you to whoever Winters was. But which of those two, Holtz exponential smoothing or Winters exponential smoothing, deals with seasonality? Like that question on the test is like, if we say like, which of these deals with seasonality? I'd have to say Winters, yeah. It's like, thank you for whoever Winters was. Watch it like you have named it after that. Yeah, I hope so too. No, Winters, it's the easiest one to remember, like when it comes to like Holtz Winters method for exponential smoothing. Holtz deals with a trend and Winters deals with seasonality. So easy one to remember right there. We haven't learned exponential smoothing yet. That'll be coming up here pretty soon, but you could maybe look at something. This is mostly trend. What was the one? It was the calves in Tasmania. Let me filter that data because that was our last question. If you have more questions, let me know. But Shiv, how's this looking? Shiv, did that cover everything? Let me know if you're wondering additional things. We're just trying to run a transformation, compare the two, think about good ways to plot it. You can always do it in Word afterwards. If you're like, hey, I don't know how to use GG or range or things like that, you can always pause my screen too. But if you're like, hey, my code's just not doing it, you can always edit in Word afterwards. It's fun to make the graphics inside of R, but you can always do your editing post in Word. So New South Wales, we want to go back to Tasmania. Let's go back to Tasmania. There's those pigs in Tasmania. And we don't want to look at pigs anymore. Let's go here to Australian livestock. Look at those calves. No. It was just calves, was it? Cool. Yep, that was it. Okay. Let me rerun the decomp this way. Decomp. Oh, that shouldn't be that high. Yes. This was what you were asking about, Abigail. Remember how you said this one is a lot more seasonality? Yeah, you got it. Awesome. This one, the major component of this one is the seasonality right here. We are doing an additive model, and I really feel like we should be doing multiplicative. Let me change that down here in the code and see if that picks up a bigger component, which goes back to question 4. We're really talking about question 4 again right now to compare two different decomp methods. So we should be able to go down here, and the X13, let me change the way it's running. So it should be an additional argument inside of here. We should be able to change default, seasonal, all that stuff. We should be able to change it. Where's my change of the stuff? Arima. Let me go look at the book. Do you have a go-to transformation you try? A lot of log transformation. I'd say if I had a go-to method, it'd be logs. But Box Cox covers it all. So that's the best thing about Box Cox is you can just say like, well, let's just it checks logs. So if you want to do a transformation, you can. It's kind of lame because it's kind of like, well, let's just do boxcocks because it'll look through. But maybe you should try some like log 10 transformations or stuff like that because that's going to pull in extreme values. I guess we used to have to like know what each transformation did, and then you just kind of run it now by itself. Can we not change the method by which it's doing it? Here, wait, it's doing a multiplicative. X11. Oh, is it choosing for us? Oh, the X13. I think the X13 is choosing the best one for us. So if you take a look at this, it's going to decide when we make this if we should do multiplicative or if we should do additive. It doesn't even let us pick. So wow. Find in topic. Multiplicative. Really? Okay. The outlier special is used to perform automatic detection of additive outliers. Cool. Yeah, it looks like it's choosing it for us. That's interesting. Yeah. A lot of these algorithms and stuff decide what is best for you, but you can always override them and make your own, at least if you want to just do a decomp. We could go by the classical method, which we do have the classical code still on here. Or do we not have the classical code anymore? Let's go grab the classical decomp. There's classic decomp right here. And that's using that right there. Where's our classic decomp? Do we run the classical decomp today? Well, let's go do it. There's type equals additive. Classical methods. Let's go do a classical method. All right, here's the classical method right here, STL decomp. And there it is, the STL decomp, the trend, robust equals true. And let's go in here. What? Classical decomp. Here we go. There we go. Type equals additive. Yeah, if you have more questions, feel free to ask. Let's copy the code. I always forget there's that button in the book, which is so nice. Okay, so we're going to take our filtered data. Filtered data. There it is. Filtered data. We're just going to take the count. And this is what's awesome. Cool. It did it. This is picking up more seasonality. So this goes back to question 4 right now. So Shiv and Abigail, this is picking up more seasonality and more remainder though. So it's more remainder, more seasonality. And do I have the other graphic right before it? The size of the original, I wish it kept those constant. Trying to detect big differences. Now we could do is we could store this auto plot into P1. We're going to look at them side by side here in a second. For graphic 1. And then we could store the second auto plot into P2. And then we can go here to GG arrange. And we can look at P1 versus P2 together now. And so we're in cool. So looking at these two, I don't like that the titles are a little bit off. Is there a way to tell what component it picked up without running the decomp code? You probably need to plot it. Do you know why my points aren't showing up in the plot plane? You might be using ggplotly can have issues. Are you using a ggplotly, Shiv? Sometimes ggplotly can have issues. Sometimes ggplotly can have issues. Does that make sense? Sometimes ggplotly can have issues. So it might be ggplotly. So I'd remove a ggplotly if you have it. Is there any way, and then is there any way to tell what component it will pick up without running? I mean, we can look at the original series and you can see that that's a lot of seasonality. I know that there's going to be a major seasonal component. The trend is going to be a smaller component. So, really when it comes down to this, and it might be that the X, if you look at the scale, this goes from negative 5,000, that's a scale of 20,000. So the X13 is picking up on more seasonality and it also shifts to seasonal patterns. This right here is allowing for what it looks like a multiplicative decomp. I've only used autoplot. Here, Shiv, I'm going to look at your code next right here. The remainder I see one problem with the remainder right now of the X13 decomp. This one's got problems too. Do you have any ideas what I see a problem with the remainder right here? At least, I mean, both of them have... That's not good either. We'll explain what we want with the remainder, and then we'll look at Shiv's code here in a second. But they're good, but we got problems. Like, there's things I don't like about that remainder. We have to know what we're looking at. The trend component really doesn't exist. There's no real linear pattern to this. So the trend is negligible. There's really nothing much going on, especially here towards the end. There's a little bit of trend apparently at the start, but I don't really even see it. The trend looks more kind of noise, which is funny because it's the smallest component. The problem with the remainder, these are all like what we have left over at the end, which is like a residual, is we're seeing large spikes. So the trend and the season are not accounting for like the large jumps right here, and that is an issue. We aren't really explaining this. We're like saying I can't explain these portions down here using these methods to break apart this series. You want this to be the smallest component. The decomp right here is not doing such a good job. The decomp that is doing better, this decomp is doing better. See, even I reverse it sometimes. Because remember, this is over a smaller scale. This one goes from negative 5,000 to 1,500. Still over a kind of big scale, but we're picking up more components of the following, especially within the seasonal. So the X13 decomp, this is how I would do a comparison, like talking about your methodologies. Does this make sense here, Abigail? This is like a lot of question number 4 right now. The X13 decomp is picking up a lot more seasonality and leaving less in the remainder by virtue of the scales on the side showing that seasonality is picked up more. Neither of these pick up any real trend component. And we see right here that in the classic decomp method, the seasonality and the remainder are very similar in their size. So I would preferably go with the X13 decomp that is picking up more of a seasonal component. It is also picking up the irregular or the shift in spread of seasonality. So I would say I 100% would go X13 decomp here. So an X13 decomp is going to do a little more advanced stuff. Once again, that's, I think, the U.S. Census Bureau came up with X13 decomp. Latest version's out from 2020 or so. So very recent advanced algorithm right there. So we're literally doing the most recent cutting edge statistics by using these algorithms, which they've created to decompose these series into the components of what they are made of. And so to Shiv's question, let me hop over to the main screen. And great work, everyone. This is a really good review of what we've been doing in class. And I just like doing that. I like going through. Shiv right here. Got it. Okay. I'm going to run these right here, Shiv, for 2A. Let me go take a look. Great work, Shiv. Good practice. Okay, you're filtering it through. You're filtering. I think the issue is the select GDP. Remove off the select GDP. Okay, it's working for me. Shiv, can you send me a screenshot of the error you're getting? Send me a screenshot. Oh, wow, that one looks a lot better. It's working for me, Shiv. Send me a screenshot of the error you're getting. Yeah, great job, Abigail. Really great review of 475 today. 201's taking a little nap. 201 had their big test last night. So, Mewbot just talking away right there. It just doesn't show up on the plot. Oh, that is probably... Let's go take a look at that. Here we go, Shiv. Ready? I'm guessing, do this follow along with me right here, Shiv, is go here to Tools, and under Tools, go to Global Options. So go Tools, Global Options right there. Under Tools, Global Options, go down to our Markdown, and uncheck this box. So uncheck that box right there that says Show Output Inline for all Markdown documents. So make sure this box is not checked, and then click Apply and OK. And then try rerunning. I think you're running inside of a chunk. So that option right there has your output appear below chunks, not over in the plot window, which I preferred in the plot window. It's a plot window. What else is it for? Yep. And so did that fix it there, Shiv? Your code's looking good right there. So not the code. Your code's looking good. And yeah, you can select the column or not select the column. Yeah, Shiv, 100 points. Thank you for asking. Yeah, You're welcome, Shiv. Great answers. Great questions, great answers. But yeah, that's what we're here to do. Just you got question, we got answers. That's what we do. Might end off here in a moment. Grab a little bit more lunch, but good stuff. So I wouldn't have to. Yeah, you don't have to select GDP. Let me show that real quick right here. Since so you can look at what we have at this point. That works fine actually. I think at this point, because what you could do. So let me show you like multiple ways to do this. And let me just say this: 100 points, your code works. That's what matters. Okay, so your code works. It's got a little bit of redundancy in the idea of what we're doing. If you select GDP, you actually don't need to put anything in the auto plot. It'll assume you're doing GDP because that's the only vector in the data set now. And what do I mean by that? I mean, you only have GDP, year is the index. So it's not going to plot the year because that's the index on the bottom of the plot. So it's only going to plot GDP because you've selected it. But what you could do is you could select GDP with the auto plot. And so does that make sense here, Shiv? Like these are 3 ways to achieve the same goal. It's just there's a little bit of redundancy here. So you could, once you get down to this, tell it from this data set. But Shiv, once again, I want to throw another 100 points because, so don't worry. Here's the thing. What you did works. So don't worry that it's got redundancy because you'll see a lot of my code of redundancy. Yeah. So I thought that was the issue, like why it wasn't plotting. And then it obviously still ran. You're welcome, Abigail. Great work right there. Yeah, autoplot is pretty smart. It'll assume that you want to plot a variable. So if you only have one measure, measures are what we're trying to measure in time series. If you only have one measure, it'll then select that one. I'll see you in class, Abigail, here pretty soon. Shiv, do you have more questions? Let me know what you're thinking. We'll see here. We'll see if 320 has questions. 320. Big assignment this weekend. You're welcome. I'm going to probably grab some lunch. I was wondering if you go 1C. Of course, Robbie. Great to have you here. Thank you, Robbie. Let's go do 1C. Let's go to the main screen. Okay, it's time for some 1C. Robbie, so great to have you here. 1C. Which one part of 1C? 1C's got a lot, I think. So which part of 1C, Robbie, are you wondering about? Oh, I'm not longer on a camera. Which part of 1C are you wondering about? Logged out of Canvas, but I've got it open. C2, 1C, C2. Okay, let's go here. Oh, we didn't do that whole summarized thing. Shiv, we'll need to look at that. Maybe we'll do that in class today. Shiv, thank you so much. So many amazing questions. And Abigail, too. And Robbie, so good to have you here. But Shiv, just so many great questions about what about this, what about that? Like, that's what we're here to do. Ask those questions. I just got a haircut. Assignment 5. Question 1C2. Okay, let's go look at some 1C2 question 5. And here we go. Let's go. Okay. So for this question, we need to write out the regression equation using the actual variables. Okay, so we need to make a regression equation. So I'm going to do a different sort of regression equation, but I'm going to write it out. Does that make sense, Robbie? Like I'm going to write out a regression equation, but write out a different one. So very similar to what you're doing, but I was doing different work with them. I'll always kind of do something a little bit different so we can kind of get in the practice of solving a question and being like, oh, well, this is what we do and get our toolkit ready. So write out the regression equation. So we need a regression. Let's get a regression. A regression is going to be simply fitting a line to a data set. Example work, not actual question. But it's going to be the same theory behind what we're doing. And so we need to create a model, and that stands for M for linear or just model, which we're going to store a linear model into. This is a function, so we open it up to put things inside of it. And then we put here something like the weight of a car explained by the horsepower of a car. So I'm using a data set called MT-Cars. You won't be using this, not your data. Don't do this. If you're doing this, you're not doing your question. But you need to create your y variable, your x variable. So this is the format y tilde x comma data equals the name of your data frame. And so what you're seeing right here is I am looking at the weight of a car explained by the horsepower of a car. And let's just make sure we know exactly what we're looking at, that the MT-Cars data set is just a what again? Robbie, what are you looking at right here? This is just a what when you see it. If you look at that, you'd say, Brian, I'm just looking at a what inside of R currently. And here's another one on the right side of it. Like, we never want to overcomplicate what we're looking at. It's just like, okay, in this very big, expansive R program, I'm just seeing a what right now. So R is just literally taking a what right here. Look at this program right here, which we all kind of know and have seen multiple times. R just has a what currently open in it. No, these are variables. Good answer there, Robbie. These are variables. And we think of this as just an Excel spreadsheet. Does that make sense that this is just an Excel spreadsheet? Like over here right here in front of me is an Excel spreadsheet, literally. And this is just an Excel spreadsheet too, with different cars. And here's the Lotus. Got one of those in my garage. I don't even have a garage. And the miles per gallon of the Lotus, or we just sorted it another way. How did I get the Lotus at the top? Where's the Lotus? I don't know. It's gone. There's the Lotus. So we have the miles per gallon, the cylinders it has, the DISP. I don't even know what that is for cars. The horsepower, HP. I play too many video games. The weight of a car, all these different things right here. That's just information collected on that car. So we want to see if the weight of a car can be explained by its horsepower. Maybe it's something like cars that have higher horsepower weigh less. So we're going to make a linear model to look at this Y variable explained by this X variable from data in this Excel spreadsheet. So now what we need to do, and this is not part of this question, but important to others, is to visualize the model. And what we noticed right here, and it goes against what I thought because I don't know cars, what we see right here is cars that have higher horsepower tend to weigh more. I guess that makes sense. If your car weighs more, it should probably have more horsepower. There might be some issue with nonlinearity though. It's mostly linear up to about the 250 point. So these two cars right here don't go strong with the linear trend, having very large negative residuals. So there is a bit of non-linearity at the end of this model. It's only 2 points, but I am a little bit worried nonetheless. So now the question becomes, we are trying to find the equation for this red line. How's that looking, Robbie, right there? Does that make sense? We are trying to find, like, let's write this line mathematically. Like, how could you write that line mathematically? Are you following me on that? Like, mathematically, how do we write the equation of that line? Like, it's going to be a little y equals mx plus b, but we're going to do it the statistics way. Now, Robbie, if you had to guesstimate, think going back down here further, where do you think the red line would hit 0? Let me try doing it this way so you can see a little bit better of a plot of it. Where do you think that red line is going to hit 0? Where do you think that red line? Oh, man. I don't know how to do the exlims on this graphic. Where do you think that red line hits 0? That's a bummer. Where do you think it would hit 0? This is a very important question because we're about to see that number. So just take a guess where, if we were to take this and extend it further, and if I were to go here, I'll draw it visually because I can't get R to do it today. I can Google some code. But if we were to extend this, we were to take right here this black pen and we were to say, 0 is going to be over here. And we were to extend this line down. Where do you think that would hit 0? And why is that value important to us? Why would this value be important down here? So any guesses, Robbie, on where would that hit 0 and why is that important? Not quite negative. So not quite negative. So think about, we would want to say that this is where, and good guess right there, Robbie, good guess. This is about at 1. So if you had to guess, it's going to hit 0 about at what? So where about does that hit 0? Maybe 1 point what? Like maybe 1.25, maybe. I think 1 point. I'm going to go 1.6. Let's go right here. 100 points, Robbie. I'm going to go 1.6. And the answer to the question is it hits 0 at 1.8. 1.8. So that hits 0 at 1.8. And how do I know that? Because that is the what intercept. This right here, this value of 1.83 is the what. That value of 1.83 right here, if we could see it visually, that value is the what intercept. That is the what intercept. It's where it intercepts the what axis. So that is the what intercept mathematically. It is the estimate of the what intercept, the y-intercept. Robbie, great work right there. So that's the estimate of the y-intercept. But we don't just need a y-intercept for a line. We need a what for a line. We don't just need a y-intercept for a line. What other value do we need for a line? We don't just need a y-intercept. The y-intercept is just one component of writing the equation for a line. We also need a second component right here, the slope. So we call these values b0 for the y-intercept and b1 for the slope. So those are the notations for these values in statistics. B0 is easy to remember because it's B0 when x is equal to 0. B1, now we don't say for each 1 unit change, but it is kind of for 1 unit changes. But don't interpret it that way. On the test, you'll lose points because we have more exact interpretations to talk about it, not just like cause-effect changes. So if you remember, B1 is like when x is changing by 1. That can help with the memory of what B1 is. It's related to the x for its kind of 1 unit changes or multiple unit changes. But B0 is a specific point at which x is equal to 0. So B0 is a great one to remember that way. When x is equal to 0, we expect, so if a car has 0 horsepower, we'd expect it to weigh 1.83 tons maybe. I think that's in tons. But I don't think a car can have 0 horsepower, so that's an extrapolation of the model. Okay, so now we have to write this equation. Well, here's what we can do. We can go here, and I think this will knit. We'll double check. We're going to take right here and say predicted weight equals to, and I'm going to put it in double dollar signs today. I think we'll see if it knits properly. It's going to be the big question. Predicted weight is equal to, and then we have to remember the equation B0 plus B1x. Okay, so this right here is the general form of the regression equation. So how's that looking, Robbie? Yes or no? Does that make sense? Like y hat, technically, y hat equals b0 plus b1x. Y hat equals b0 plus b1x. So the predicted value of y, which is the line itself, is equal to the y-intercept plus the slope coefficient times the x value right here, whatever the horsepower is. So now this is not the answer because we haven't given it context. So we just put it in a second ago, and let's add it back in. When we're talking about y, we're talking about the predicted weight. It's really good we say predicted, not just weight. It's going to give it more context to tell someone this is not the actual weight, it's what we predict the weight to be. The actual weight for this car is a little bit higher than 3.1, but it's predicted to be about 2.2. It's a very high positive residual for this car right here. But Robbie, what is going to be the value of B0? What should I input right here into it? And you can tell me to 2 decimals or 3. We might have to do 3 because one of them is very small. What value should I put right there when writing the equation of this line to put in the estimate of B0? So remember what B0 is, kind of a review question right now. Great job, Robbie, another 100 points. That is that estimate right here. We're just going to copy paste, boom, copy paste. We love copy paste. And then I bet you know, you can just tell me the B1 is going to be what? And we're almost done. You got it, Robbie. And we'll do another one right here if you got time. What is going to be B1? What is B1? B1 is the slope coefficient or the estimate of what we think the slope is. And there it is, it is the slope. We'll just take that right here and we'll drop that right in here. There's the slope. And then we're going to take right here and we're going to multiply that by horsepower, which is the name of the x variable. I might put in a little parentheses. Either which way is fine. Multiply. It's your preference. Now what we are going to do is we are going to knit this to make sure it works. When I say knit, we're turning it into a Word document here. It's basically just writing this all down into a Word document for us. We're going to hope that everything knits properly. Do try to knit your assignment every so often. Everything looks to be knitting. We're pretty good right here. Okay, good. I'm going to scroll down here, and I'm going to see if that equation's in there, and the equation did knit. So you see right here all that stuff I did, and I could have just wrote it in Microsoft Word. If you really want, when you get into Word, you could go right here and add a little hat over that. I mean, if you're Brian, you're going to do that. If you're normal, you won't do this. Because then, technically, now we don't need the predicted before it. Now we can say that way. So now it is, with the hat on top of it, it is predicted weight. So that's just notation right there. Instead of it being the actual weight, the hat over top of it, which I don't know how to add via R, so I would do it in post. The hat over top of it says predicted weight of a car is equal to 1.838, which is the intercept, plus the slope coefficient of 0.00941. What do you think about next right here, Robbie? Does that make sense on what you're trying to do? You need to take from this output both the intercept coefficient and the slope coefficient and use them in the B0 plus B1x and make sure to give it context right here. If you want, Robbie, we can do another one right here. We still got 8 minutes, but what are you thinking? And 100 points. You're welcome, Robbie. What are ones you think about? And we do have later office hours, so if you're still working on this later, I bet some people might be saying, hey, Robbie, that helped me out a lot, because that's how we write the regression equation right here. Let's jump back to the main screen. Here we go. If you got time, Robbie, we got time for one more. You got this right now. It's all you. Whatever you like. I bet you other people say, oh, wish someone's gonna be looking at this video. Yeah, 1C. Which one 1C? I think 1C's got a lot of components, right? 1C, C3. You bet we got time. Ooh, I like these. You know, we're gonna do 1C3 and 1C4. So let's do interpretations of slope and intercept. Let me take some notes right here. We're gonna do both of these because these are both very important and one is easier than the other. So we're doing 2 for 1 right here. So BAS 320, assignment 5. Question 1C, 3, and C4. Okay, let's check this out. So the first thing you need for these questions are going to be your coefficients. So when it says, and know this for the test, if it says interpret the intercept, well, first off, you need to know what the intercept is. The intercept is the estimate of the intercept. Like, I know you're like, well, that's not the intercept, that's the estimate. Well, yes. We don't know what the intercept is. We'll never know what the intercept is. We can only estimate what the intercept is because we'll never have all the data. So we take a reasonable estimate of what we think the intercept is, and that's our reasonable estimate. So now with this right here, we have our estimate of the intercept and we need to interpret it. So what does the intercept mean? Well, the intercept here is actually, let's do it 2 ways. One, so just some notes. Don't include these. Well, that's kind of number 2. 1. Okay. So, Robbie, just a very quick, I'll give you a full explanation right here. I want you to think about these cars, and I want you to talk to me. The intercept would be the expected value of a car that what? The intercept, which remember we drew it out over here. Yep, we still got it over here. The intercept, and I'm going to decrease some of the drawing on this picture. The intercept, which is down here, we got it circled right now. That is the value of the intercept, is a car which what? So I'm going to circle some more stuff to help, but just talk to me a little bit about this. Talk to me about that. It's the expected value of a car that what? This would be the expected. Now, don't say will. We've got to be careful. Words like will show certainty. We don't want to show certainty when we talk about things in statistics. We want to say these are estimates. This is our best guess or our predicted. There's multiple ways to say it. You just don't want to use words that imply certainty. Oh, you got this, Robbie. Good. Take a guess. You got this. I got faith in you right here. So any sort of guess. So remember, don't use words that imply certainty like this car will have this. But tell me a little bit about the car. What do you know about this car? I'll point to some hints. What do you know about this car? And think about what you know, and then what you would estimate for this car. So the estimated value is blank for a car that would have blank this. So I'm trying to leave out some blanks in there. So I would estimate a car with this blank would have about this blank. When horsepower is 0, we'll keep going. For cars that have a horsepower of 0, so we'll close. Put it to a full sentence. You got this, Robbie. 100 points again. You got this. Put it as a full sentence, but don't show any certainty because we don't want to say things are things. We want to say we estimate or predict or expect. So throw in sprinkle on a little estimate, a little predict, a little expect. So think about how we can throw in those like uncertainty words because we don't want to oversell things. We want to say, aha, this is what it will be. So what would you throw in there? A little estimate, a little predict, a little expect. When the horsepower is 0, we predict the weight to be 1.8. Awesome. Robbie, another 100 points. Great work. When horsepower is 0 for cars, we predict the weight to be around, I would say we predict it to be this. That is, So don't use the around there. You threw a little too much salt on. I would just say we predict the weight to be this. When horsepower is equal to 0, we predict the weight of a car to be 1.838. That's the predicted weight or predicted horse. Oh my gosh. That is the predicted weight. It's the Y value. That is the predicted weight of a car that has a horsepower of 0. Second question. Does that make sense? If your car has a horsepower of 0, I don't think your car runs. And that's probably what we need to say to someone. When I ask, does this make sense? I think people overanalyze the idea of does this make sense? The idea of does this make sense is you just say, horsepower of 0? I don't think cars can have horsepower of 0, so I don't think this makes sense. So my full interpretation would be, when a car has a horsepower of 0, we predict its weight to be whatever this is. Let's say tons. It's tons. This is not meaningful because cars can't have a horsepower of 0. Does that make sense, Robbie, right there? That would be my full interpretation. Like when a car has a horsepower of 0, because that's what the X and the Y-intercept is, we predict its weight to be that amount of tons. This is not meaningful because cars can't have horsepower of 0. So the intercept is not really something of value to us. We can't really use it to make predictions. That's what we mean by meaningful. Like, no one's going to really be talking about cars of horsepower of 0. So that's not good right there. Now we get to the big one, the slope. And so I'm going to write out a bit of interpretation right here. The slope is the one that people miss on the test. The number one thing to know is you get a cheat sheet for the test. Use your cheat sheet. Use your cheat sheet. 2 blanks that differ in X. Now, got to do his comments. That differ in X by 1 unit are expected to differ in Y by B1 units, where the blanker blank is expected to be higher / lower in Y. Okay. Higher, yeah. Yeah, the higher, I think that works right there. Cool. It's a lot. But it makes sense when we put it together, and I'll show you. You don't want to say things like, when a car's horsepower increases by this much, its weight increases by this much. Let's say someone puts a new engine in their car and they get a ton of horsepower. It's not like the weight of the car is going to be dramatically shifted. It might, but this is not cause and effect. So we have to be careful. Do not use the following. For each 1 unit increase in, do not use this. 0 out of 4 points on test. Implies cause and effect. Do not use that. Do not use that. You must use this up here, and I'll explain why. What we're comparing is we're comparing 2 cars in this data set. We are comparing 2 cars literally when we talk about this. This model right here is meant to show us the differences expected between a car over here and a car over here and their expected difference. That's what that line is showing us, an expected difference between 2 cars. And these 2 cars are going to differ in their horsepower. It's not about how one car changes if it gets more horsepower. It's about the expected differences between these cars in their data set, and we compare the cars and we talk about what we would expect to see. So 2 cars, select any of them. If they were to theoretically differ, these 2 cars, by 1 unit of horsepower, the expected difference in their weight would be 0.009. So 2 cars that differ in their horsepower by 1 unit of horsepower are expected to differ in their weight by 0.009, where the car that has more horsepower is expected to weigh more. This is the quickest and easiest thing to understand right here, where the car that has more horsepower, the higher X, is expected to weigh more. So 2 cars that differ in their horsepower by 1 unit of horsepower are expected to differ in their weight by this amount. That's just what we expect. It's not saying they will. Don't use will. We're expecting them to differ by that amount. Where the car that has more horsepower is expected to weigh more. Robbie, how does that look? Try to use this for your interpretations right here, but is that looking pretty good? Let me know if you have questions. Since I'm about to do a class here in 18 minutes, I need to send out those announcements. How's that look, Robbie? Head over to the main screen. Let me know if you have questions right now. We got this. And Robbie, swing by afternoon office hours if you like. Oh, I'm logged out of Canvas, so I won't be able to send announcements. No. Awesome work, Robbie. You're welcome. We'll be back here later today. Swing by for more office hours. Work on more questions. Bye for now, everyone. Bye.